June 13th, 1944, 15,000 feet above the Normandy beaches, Hauptmann Klaus Mituschka of Jagdgeschwader 26 pulled his Focke-Wulf 190 into what should have been an impossible turn at 380 miles per hour. The G-forces should have locked his controls solid. Instead, his aircraft responded with lethal precision, closing on a formation of British Typhoons returning from close support missions. What Mituschka didn't know was that climbing toward him from below was Flight Lieutenant Pierre Clostermann in a Hawker Tempest 5, an aircraft equipped with a revolutionary control system that would redefine the limits of high-speed fighter combat. As Clostermann pulled his Tempest into a climbing turn that would have been suicidal in any other fighter, his spring tab-assisted controls responded with silk-smooth precision. The French ace banked hard left at 420 miles per hour, a maneuver that German aerodynamic theory declared impossible without catastrophic structural failure. Within seconds, Clostermann's 420mm Hispano cannons were aligned on Mituschka's Focke-Wulf. The German pilot never understood what hit him. His last radio transmission, intercepted by British intelligence, captured the bewilderment of the Luftwaffe's elite. Impossible maneuver. How do they turn at such speeds? The answer lay in a deceptively simple innovation developed by Hawker Aircraft's chief designer Sidney Cam and his team of engineers. Spring tabs, small auxiliary control surfaces that reduced pilot workload and maintained control authority at extreme speeds, had transformed the Tempest into the world's most maneuverable high-speed fighter. What German pilots experienced as supernatural agility was actually applied aerodynamic science, British engineering excellence meeting combat necessity in the crucible of aerial warfare. The Hawker Tempest had emerged from the recognition that existing fighters couldn't match the performance of German radial engine fighters like the Focke-Wulf 190. The Typhoon, despite its powerful Napier Sabre engine, suffered from poor high-altitude performance and structural limitations. Sidney Cam's team began development of an advanced variant in early 1942, incorporating lessons learned from combat over Europe and the Channel. The Tempest featured a redesigned wing, more powerful engine variants, and most crucially, an entirely new control system based on spring tab technology. Spring tabs represented a revolutionary approach to flight controls. Traditional control surfaces required pilots to overcome increasing aerodynamic forces as speed increased. At 300 miles per hour, a fighter's controls became heavy and sluggish. At 400 miles per hour, most fighters became nearly uncontrollable, with pilots struggling to make even basic maneuvers. The spring tab system used small auxiliary surfaces connected to the main controls through a spring mechanism. As airspeed increased and control forces grew, the spring tabs automatically assisted pilot inputs, maintaining light, responsive controls even at extreme velocities. The engineering was elegantly simple yet devastatingly effective. Each control surface carried a small tab connected to the main control through a torsion spring. When the pilot moved the control stick, the spring compressed, activating the tab. The tab created aerodynamic forces that assisted the main control surface movement, reducing the force required from the pilot. At low speeds, the spring barely compressed, and the system had minimal effect. At high speeds, where control forces would normally become prohibitive, the spring compressed fully, providing maximum assistance. German fighter design philosophy had emphasized different priorities. The Messerschmitt Bf 109 achieved excellent performance through lightweight construction and minimal equipment. The Focke-Wulf 190 used innovative radial engine installation and careful weight distribution. Both aircraft featured conventional control systems that became increasingly difficult to operate as speeds approached 400 miles per hour. German pilots compensated through superior training and tactical discipline, but they couldn't overcome fundamental aerodynamic limitations. The contrast became apparent during the first encounters between Tempests and German fighters in July 1944. Squadron leader Pierre Klosterman of Number 3, Squadron RAF, described his first combat mission in the Tempest. The aircraft felt alive in ways the Spitfire never did. At speeds where the Spit's controls locked up, the Tempest danced. I could outturn a 109 at 350 miles per hour, something that should have been impossible. German pilots reported these encounters with growing alarm. Oberleutnant Hans-Joachim Jabs of JG-26, a veteran ace with over 30 victories, encountered Tempests during a bomber interception mission on July 20th, 1944. His combat report captured the German confusion. The British fighters maneuvered at speeds I estimated at 380 to 400 miles per hour. My Focke-Wulf's controls were locked solid at such speeds. I could barely maintain formation, yet they were dogfighting. This contradicts everything we understand about high-speed aerodynamics. The technical specifications told the story of British innovation. The Tempest V's spring tab system reduced control forces by approximately 60% at speeds above 350 miles per hour, where a Focke-Wulf 190 required 80 pounds of force to achieve a 4G turn at 380 miles per hour. The Tempest needed only 35 pounds. This difference meant German pilots fighting at the edge of their physical capabilities, while British pilots operated comfortably within normal parameters. Combat reports from the summer of 1944 revealed the devastating impact of this technological advantage. During the period from D-Day through August 1944, Tempest squadrons achieved a kill ratio of approximately 4-1 against German fighters. This superiority occurred despite German numerical advantages and extensive combat experience. The spring tab system had fundamentally altered the dynamics of aerial combat. Wing Commander Johnny Baldwin, commanding number 146 wing equipped with Tempests, observed the tactical revolution. Jerry would dive on us at maximum speed, confident that we couldn't respond effectively at such velocities. Then we'd turn inside him at 400 miles per hour and put 4 cannon shells through his engine. They never adapted to what our aircraft could do. The psychological impact on German pilots was profound. Combat had always involved calculated risks based on known performance parameters. Luftwaffe training emphasized exploiting the weaknesses of Allied fighters. Spitfires lost maneuverability above 350 miles per hour. P-51 Mustangs became sluggish in high G turns. These limitations could be exploited through proper tactics. The Tempest violated these assumptions, maintaining agility where other fighters became uncontrollable. General Major Adolf Galland, commanding the Luftwaffe fighter arm, received disturbing reports about British fighter capabilities in August 1944. His staff compiled intelligence suggesting that a new British fighter possessed supernatural maneuverability at high speeds. Initial assessments dismissed these reports as pilot error or exaggeration. Combat-stressed aviators often overestimated enemy capabilities. But reports continued arriving from veteran pilots whose assessments had always proven reliable. The technological gap extended beyond individual combat. The spring tab system enabled new tactical formations and maneuvers impossible for conventional fighters. Tempest squadrons could maintain tight formations at speeds where German fighters struggled to fly straight and level. This formation discipline translated into concentrated firepower and mutual protection that devastated German attacks. Flight Lieutenant David Fairbanks of No. 56 Squadron recorded a typical engagement on August 15, 1944. 8 Focke-Wulfs bounced us over Caen. We were at 380 miles per hour when they attacked. Instead of breaking formation, we turned as a unit into their attack. They couldn't follow the turn at that speed. We had them in our sights within seconds, shot down 4 without loss. German pilots began reporting that British fighters seemed to operate under different physical laws. The Tempest's ability to maintain control authority at extreme speeds created tactical options that German training had never addressed. Traditional evasive maneuvers became ineffective when the pursuing aircraft could follow every twist and turn at maximum velocity. The engineering team at Hawker had solved a fundamental problem that had plagued fighter aircraft since the beginning of aviation. As aircraft became faster, they became less maneuverable. The spring tab system reversed this relationship, allowing fighters to become more responsive as speeds increased. This breakthrough represented a paradigm shift, comparable to the introduction of the monoplane or retractable landing gear. Sidney Cam's design philosophy emphasized practical solutions to combat problems. Unlike German engineers who pursued theoretical perfection, Cam focused on giving pilots what they needed to survive and win. The spring tab system exemplified this approach. It wasn't elegant from an engineering perspective, but it was devastatingly effective in combat. Production of the Tempest 5 began in earnest in early 1944, with the first operational squadrons forming in April. By D-Day, 3 squadrons were equipped with the new fighter. Production accelerated through the summer, reaching peak output of 150 aircraft monthly by September 1944. Each Tempest required approximately 10,000 man-hours to complete, with special attention paid to the precise calibration of the spring tab system. The spring tabs themselves were marvels of precision engineering. Each tab measured approximately 18 inches by 8 inches, connected to the main control surface through a system of springs, levers, and connecting rods. The springs were manufactured to exact specifications, with tolerances measured in thousandths of an inch. Too stiff, and the system wouldn't activate at high speeds. Too soft, and it would interfere with low-speed handling. German intelligence gradually pieced together the secret of Tempest performance. Captured aircraft were thoroughly examined, with particular attention paid to the control systems. German engineers quickly understood the principle, but struggled to implement their own version. The spring tab system required precise manufacturing tolerances that German industry, under constant bombing and resource shortages, couldn't consistently achieve. Focke-Wulf attempted to develop their own spring tab system for the FW190D variant in late 1944. Prototype tests showed promise, but production aircraft never received the modification. The combination of manufacturing difficulties, material shortages, and the rapidly deteriorating war situation prevented implementation. German pilots continued flying fighters with conventional controls while facing opponents with revolutionary technology. The performance gap widened as both sides gained experience. British pilots learned to exploit their aircraft's capabilities, developing new tactics based on high-speed maneuverability. German pilots, constrained by their aircraft's limitations, couldn't adapt effectively. Traditional Luftwaffe advantages in training and experience became irrelevant when the opponent possessed superior tools. Major Georg Peter Eder, one of Germany's most successful fighter pilots with 78 victories, encountered Tempests during the defense of Germany in autumn 1944. His assessment was brutally honest. The new British fighter changed everything. We had always relied on superior aircraft performance to offset their numerical advantage. Suddenly, they had better aircraft too. The Tempest could outturn our best fighters at speeds where we could barely control our machines. The spring tab technology enabled combat maneuvers that redefined aerial warfare. The Tempest could execute 6 G-turns at 400 miles per hour, maintaining formation integrity while German fighters struggled with basic control inputs. This capability allowed British pilots to maintain offensive pressure even when outnumbered, confident that their aircraft would respond to emergency maneuvers that would be impossible in conventional fighters. Combat film analysis revealed the devastating effectiveness of spring tab-equipped fighters. Frame-by-frame examination of gun camera footage showed Tempests maintaining stable firing platforms while executing violent evasive maneuvers. German fighters in the same footage appeared sluggish and unresponsive, unable to match the British aircraft's agility. The visual evidence confirmed what pilots reported. The Tempest possessed a fundamental performance advantage. advantage. The tactical implications extended beyond individual combat. Squadron-level engagements became increasingly one-sided as British fighters could maintain coordination at speeds where German formations disintegrated. The ability to fight effectively at maximum velocity meant that British pilots could choose when and how to engage, forcing combat on their terms. Wing Commander Johnny Johnson, Britain's top-scoring fighter pilot, flew early combat missions in the Tempest and immediately recognized its revolutionary potential. The spring tabs weren't just a technical improvement, they were a war winner. For the first time, we had a fighter that became more dangerous as the fight got faster and more violent. Jerry couldn't cope with that reversal. German fighter doctrine had evolved around the limitations of high-speed combat. Pilots were trained to manage control forces, use trim tabs effectively, and avoid extreme maneuvers at maximum velocity. These techniques became counterproductive against spring tab-equipped opponents who faced no such limitations. German tactical manuals required complete revision, but with the Luftwaffe's training infrastructure collapsing, new tactics never reached operational units. The engineering challenges of implementing spring tabs had required innovative solutions throughout the aircraft industry. Hawker's engineers developed new manufacturing techniques for the spring mechanisms, created testing protocols to ensure proper calibration, and trained maintenance personnel to service the complex control systems. This industrial effort represented thousands of man-hours of development work that paid dividends in combat effectiveness. Quality control became critical for spring tab production. Each spring required testing to exact specifications before installation. The connecting linkages demanded precision machining to tolerances far tighter than conventional control systems. Assembly required skilled technicians who understood the subtle adjustments necessary for optimal performance. British industry met these challenges through careful planning and resource allocation. German attempts to reverse engineer captured spring tab systems revealed the complexity of British manufacturing. The springs themselves used alloys that German metallurgy couldn't precisely duplicate. The machining tolerances exceeded German capabilities under wartime conditions. Most critically, the integration of the spring tab system with the aircraft's overall control harmony required flight testing and adjustment that German flight test facilities couldn't provide. The Tempest's combat debut during the Phi-1 flying bomb campaign demonstrated another advantage of spring tab technology. Intercepting V-1s required precise high-speed maneuvers to position the fighter for gun attacks or wingtip disruption of the bomb's flight path. The Tempest's exceptional high-speed handling made it the most effective V-1 interceptor, with pilots like Joseph Berry achieving remarkable success rates. Flight Lieutenant Berry described V-1 interception in the Tempest. You had to approach at maximum speed to catch the bloody things. Any other fighter would shake itself apart, trying to maneuver at 380 miles per hour. The Tempest just got smoother and more responsive. I could place my aircraft exactly where needed for the kill. By late 1944, German pilots reported that encountering Tempests required completely different tactical approaches. The standard Luftwaffe technique of diving to high speed for hit-and-run attacks became counterproductive when the target could outmaneuver the attacker at maximum velocity. German fighters found themselves forced into turning combats where the Tempest's advantages were most pronounced. Oberst Johannes Steinhoff, commanding JG-7 equipped with Me-262 jets, observed that even jet fighters struggled against well-flown Tempests in certain scenarios. The Tempest pilot who understood his aircraft's capabilities could force us into situations where our speed advantage became meaningless. In a diving turn at 400 miles per hour, the Tempest was more dangerous than our jets. The spring tab system's effectiveness varied with pilot skill and experience. Novice pilots couldn't fully exploit the system's capabilities, while experienced aviators found it revolutionary. British training programs adapted to emphasize high-speed combat techniques, teaching pilots to fight effectively at velocities where other fighters became uncontrollable. This training investment multiplied the technological advantage. German pilot training, constrained by fuel shortages and accelerated schedules, couldn't address the new tactical challenges posed by Spring Tab-equipped fighters. Novice German pilots arriving at operational units had minimal experience with high-speed combat and couldn't compete with British pilots who had trained extensively in advanced techniques. The psychological warfare aspect of Spring Tab technology proved as important as its tactical advantages. German pilots who survived encounters with Tempests spread stories of British fighters that defied physics. These accounts, while technically accurate, created fear and uncertainty that undermined Luftwaffe morale. Pilots entering combat against Tempest squadrons expected to face superior opponents, a mindset that often proved self-fulfilling. Intelligence reports from captured German pilots revealed the extent of Luftwaffe confusion about British fighter capabilities. Many pilots reported that Tempests seemed to accelerate during violent maneuvers, an impossibility that reflected their inability to comprehend how aircraft could maintain control authority at extreme speeds. These misperceptions indicated fundamental misunderstanding of what they faced. The final months of 1944 saw Tempest squadrons achieving unprecedented success rates against German fighters. Number 3 Squadron RAF, flying from B-80 airfield in Belgium, claimed over 100 aerial victories between September and December 1944, with minimal losses. This ratio reflected not just superior equipment, but the cumulative effect of technological advantage, superior training, and declining German pilot quality. Pierre Klosterman's combat log from this period documented the one-sided nature of aerial combat. November 15th bounced 8 Focke-Wulfs over Munster, destroyed 3, probably destroyed 1, damaged 2. No damage to our aircraft. The Jerrys couldn't maneuver effectively at combat speeds. December 3rd engaged 12 Me-109s over Osnabrück, shot down 4, damaged 3. They seemed afraid to engage in close combat. As 1945 dawned, the Spring Tab-equipped Tempest had fundamentally altered the balance of aerial warfare over Western Europe. German fighter pilots, once the most feared aviators in the world, found themselves outclassed by British technology and training. The revolutionary control system had transformed aerial combat from a contest of pilot skill to a demonstration of engineering superiority. The post-war analysis confirmed what combat pilots had experienced firsthand. Spring Tab technology represented one of the most significant advances in fighter aircraft design during World War II. The system's ability to maintain control authority at high speeds provided tactical advantages that German conventional fighters couldn't match. British engineers had solved a fundamental problem that had limited fighter performance since the dawn of aviation. German engineers studying captured Tempests after the war admitted that Spring Tab technology was years ahead of anything they had developed. The precision manufacturing required, the careful integration with overall aircraft design, and the extensive testing necessary for proper implementation all demonstrated British technological superiority that the Luftwaffe couldn't counter with existing resources. The legacy of Spring Tab technology extended far beyond World War II. Post-war fighter designs incorporated similar systems, recognizing that high-speed maneuverability was essential for modern aerial combat. The principle that Hawker engineers pioneered in the Tempest became standard throughout the aviation industry, influencing fighter design for decades. Today, modern fly-by-wire control systems trace their conceptual ancestry to the Spring Tabs of the Hawker Tempest. The fundamental insight that control systems could enhance rather than limit aircraft performance at high speeds revolutionized aviation engineering. What Sidney Cam's team achieved with springs and mechanical linkages, modern engineers accomplish with computers and electronic actuators. The engineering complexity of the spring tab system extended beyond the tabs themselves. The entire control circuit required redesign to accommodate the variable assistance provided by the tabs. Cable tensions, pulley ratios, and control stick gearing all required careful calibration to ensure proper feel throughout the speed range. Hawker's engineers spent months fine-tuning these relationships, creating a control system that felt natural to pilots while providing supernatural performance. Test pilot Philip Lucas documented the spring tab development process in his technical reports. Early prototypes suffered from control oscillation at certain speeds, requiring damping mechanisms to prevent dangerous flutter. The tabs themselves underwent dozens of design iterations, with engineers adjusting chord length, aspect ratio, and hinge location to optimize performance. Each modification required extensive flight testing to validate theoretical calculations. The manufacturing challenge of producing thousands of precisely calibrated spring mechanisms pushed British industry to new levels of precision. The Bristol Aeroplane Company, subcontracted to produce spring tab assemblies, developed specialized tooling and quality control procedures. Each spring was individually tested and matched to specific aircraft, with detailed records maintained throughout the production process. German intelligence operatives attempted to steal spring tab technology through various means. A Luftwaffe technical intelligence unit offered substantial rewards for captured Tempest control components. Several German agents posed as French resistance members to gain access to crashed Tempest wreckage. These efforts largely failed due to the complex integration required between the tabs and the overall control system. The psychological impact of spring tab technology manifested in unexpected ways. German pilot training instructors reported increasing difficulty in teaching high-speed combat techniques to new pilots. Students who encountered Tempests in combat returned with accounts that contradicted established aerodynamic principles. Instructors struggled to explain how enemy aircraft could maneuver effectively at speeds where German fighters became uncontrollable. Oberst Werner Mölders, Germany's leading fighter tactician before his death in 1941, had written extensively about high-speed combat limitations. His tactical manual stated definitively that effective maneuvering combat becomes impossible above 350 miles per hour due to control force requirements. By 1944, this doctrine had been proven catastrophically wrong by British engineering. The final accounting of spring tab effectiveness came through careful analysis of combat film and pilot reports. British operational research scientists calculated that spring tab-equipped Tempests achieved approximately 40% better success rates in high-speed engagements compared to conventional fighters. This advantage translated directly into lives saved and missions accomplished, proving that incremental technological improvements could have strategic consequences. The German pilots, who faced Tempests in combat, carried their respect for British engineering into the post-war period. Many became advocates for international cooperation in aviation development, recognizing that technological advancement served humanity better than national competition. Their first-hand experience of being outclassed by superior engineering made them strong supporters of peaceful technological exchange. The spring tab technology of the Hawker Tempest represented more than an engineering achievement. It demonstrated how focused research and development could transform military capabilities in remarkably short timeframes. From initial concept to combat deployment required less than 3 years, a timeline that reflected British industrial efficiency and scientific excellence under wartime pressure. German pilots who survived encounters with Tempests universally acknowledged the aircraft's superiority in high-speed combat. Their testimony provided some of the most compelling evidence of spring tab effectiveness, confirming that British engineers had achieved a genuine breakthrough in fighter aircraft design. The Tempest's spring tabs had rewritten the rules of aerial warfare, giving British pilots capabilities that German fighters simply couldn't match. The revolution in high-speed fighter control that began with the Hawker Tempest's spring tabs changed aerial warfare forever, proving that innovative engineering could overcome traditional limitations and provide decisive tactical advantages. German pilots learned this lesson through bitter experience, discovering that centuries of military wisdom about air combat had been rendered obsolete by British engineers who refused to accept that faster aircraft had to be less maneuverable. The spring tabs had spoken, and the sky belonged to those who mastered their secrets.